For your fourth and final mini lecture, we'll be talking about experimental designs. Now, I told you that while developmentalists, their bread and butter are longitudinal studies, there are other areas of psychology that traditionally use more experimental design. So that would be social psychology and cognitive psychology in particular. So in an experimental design, you're able to assess causality, and this is because people are randomly assigned to different groups. So in the case of an experimental design where you have only two groups, you would have one experimental group. This is a group that's exposed to some treatment. So if they're in a randomized controlled trial, these would be the people who are getting the pill that actually has an active ingredient. This could also be an experiment where this is the group that receive some type of manipulation. So if you'll remember in the bozo doll experiment, that was a experimental design. The children in the experimental group were the ones that saw the Confederate act aggressively towards Bozo. Now, in comparison, those randomly assigned to the control group do not receive this treatment. In a randomized controlled trial, these would be the people who get the placebo pill that actually doesn't do anything. It's just a sugar pill. In the bozo experiment, the control group entered the same room as those in the experimental group, but there wasn't any kind of modeling of aggression. There were the same types of toys, so they had the same opportunity to hit the bozo doll or to pick up the toy gun, but they did not see anybody act aggressive. What is key here is random assignment. This helps avoid any unintentional differences between groups. So in an experimental design, you're aware that different people have different characteristics. So you might have people with different personalities, gender, experiences, backgrounds, but this is washed out because they have the exact same chance of being assigned to the experimental or control group. For variables in an experiment, it is important that you are able to identify the independent and dependent variable. And this can be confusing, but it really is pretty straightforward. The independent variable is the treatment, it's the manipulation, it's what the experiment is all about. It's what the experimenter has direct control over. So an independent variable could be whether or not they receive the pill, the placebo pill or the active ingredient, or whether or not they see the active aggression or not. The dependent variable is the main variable that the researcher is interested in. So say in the case of a randomized controlled trial, they're trying to lower blood pressure. And so the independent variable is which pill they get, and the dependent variable is whether or not their blood pressure goes down. In the bozo doll experiment, the dependent variable, they measured aggressive behaviors afterwards. So the dependent variable is something that may or may not change as a result of the change in the independent variable. So let me give you an example from my own research. This was my dissertation. It was called Get the Lead Out. I was trying to reduce lead exposure in children in poverty. So I recruited children who had low levels of lead exposure. So lead exposures that weren't considered lead poisoning and didn't warrant the health department coming in and helping. But any amount of lead exposure is bad, so we still wanted to get them even lower. I recruited these families from WIC, Women, Infant, and Children, Head Start, and the Health Department. And it was an experimental design because families were randomly assigned to either receive a cleaning kit or not, and receive a risk assessment or not. So the cleaning kit would help them to clean properly around the house to reduce lead dust, and the risk assessment would help them see if there is lead in their house, where it is, and provided them some guidance in how to remediate it. So in this example, there are 4 groups that people could be randomly assigned to. The first group would be if they're randomly assigned to not receive the cleaning kit and not receive the risk assessment, and that's the control group. The second group received just the cleaning kit, the third group received just the risk assessment, and the fourth group received both the cleaning kit and the risk assessment. So my independent variable was which group they were randomly assigned to. The dependent variable were children's blood levels. So I did a pre-draw and a post-draw after this study, and I was able to see if the study was effective in reducing lead levels. For an experiment, location is really interesting, and this might be where we see a lot of differences in developmental psychology. So, the example of the Bozo doll is an example of a laboratory study. And of course, when we hear laboratory, we traditionally think of beakers and Bunsen burners, but of course, in psychology, a laboratory is just a standardized room, something that controls for external factors. So if you are interested in aggression in the Bozo doll experiment, the laboratory was a room that it looked the same to every single child, and there were the same types of toys, some toys that naturally are used for more aggressive behaviors, like a gun or the Bozo doll, some toys that were benign. So the child was going into a controlled environment. A laboratory environment has the most control. But in developmental psychology, we often are interested in giving up some of that control in favor of ecological validity. And ecological validity is the idea that if you study someone in their natural environment, you're able to get a better idea of what's going on. So for Get the Lead Out, that was a natural setting because I went into the family's homes and all the homes were different. Some were much worse off than others. So there was no control. For some people, the study helped a lot because they had a lot that needed to be done. And for others, there just wasn't as much. And so the study didn't contribute as much. But I had strong ecological validity, which is very important. So when I can translate this into programming, I know that it works for typical families out in their real homes. And finally, let's talk about a quasi-experimental design. So this is when you're comparing groups that people are naturally assigned to. It's really correlational, but it allows us to come away with some important conclusions. So let me give you an example. You can't randomly assign people to have lead exposure. So if I was interested in the impact of lead exposure on ADHD, because there is a higher rate of diagnosis of ADHD for children who have been exposed to lead, what I could do is I could find people who have ADHD and were exposed to lead, and people who have ADHD but have no record of lead exposure. And I could compare these two groups to try to see what the difference is and if they're perhaps the manifestation of ADHD is slightly different if it's because of an environmental factor like lead exposure and not more genetic contributions. So that wraps it up for experimental designs. You can see why the quasi-experimental design might be more common in developmental psychology. But that being said, there are laboratory studies. One of our very own researchers, Dr. Perez, brings children into a lab here at UNF. And we do have experimental designs, as my dissertation shows. This concludes your 4-part mini-series on research methods.